Today's notes is on the idea of compound interest. Compound interest is the financial concept that if you automatically reinvest the interest you just earned on your investment, because now your investment amount is larger, your next interest amount is larger as well, and it snowballs dramatically over time exponentially. So compound interest is reinvesting your interest earned automatically, so it's now earning you more money. The compound interest formula is that if you want to calculate the future value of your investment, you multiply the principal, some textbooks call principal present value, by the quantity of 1 plus the rate divided by the number of times a year interest is compounded to the power of the product of number of times compounded by number of years you're leaving your investment alone to grow. Make sure you write down what each of those variables stand for, and if you need to pause the video to get all that down, please do. Copy down question 1. Let's say you invested $200 in an account that is compounded quarterly at a 1.5% interest rate. If you're planning to leave your money invested for 10 years without touching it, how much money will you have in that investment after the 10 years are up? So for me, a good technique for solving word problems in general that have multiple variables is to list out all the variables I know I need in my formula. So you could see I already did that on the side. And then identify all the numbers in the word problem and figure out which variable that number goes with. First number, you invest $200. So that's my present value. That's my principal. We don't know future value. That's the question, how much will you have? So we'll just put a question mark there. That's the one variable we're not going to be told, so we're solving for it. Rate, shortcut to identify a rate is rate in financial problems are pretty much always percentages. If we look at the problem, we have a 1.5% interest rate. Now, pro tip for word problems in general that involve percents. Almost every single time you have a word problem involving percents, you have to convert that percent into a decimal version of itself before you plug it into the formula. So to convert a percent, that means move the decimal 2 times to the left, and if there's a gap, put a 0 in the gap. N is interesting. That's the trickiest variable to figure out. N stands for the number of times a year the interest is compounded. In other words, the number of times a year they do the math and add an interest to your investment. You can almost always find N as a word right after the word compounded. See how our situation is that they're doing the math to add an interest quarterly. It's compounded quarterly. Quarterly, you ask yourself, if they're doing this quarterly, how many times a year is that happening? It's happening 4 times a year. So N is 4. And then T is for time in years, so 10 years. When we plug it into our compound interest formula, it looks like this. Now, if you have a pretty advanced scientific calculator, you might be able to type this whole equation in one go and get the right answer, but usually about 50% of the class is using either a calculator app or a simpler calculator that cannot understand it if you type it all in at once, and will get you the wrong answer if you do that. So most of you will have to carefully think in terms of PEMDAS order of operations, meaning you zoom in on P, parentheses first, and you do that part of the math in your calculator. 1 plus 0.015 divided by 4. Just do dividing by for that fraction bar, 4. And after PEMDAS, you need to do, after parentheses in PEMDAS, you need to do exponents, but you need to simplify the exponent so it's a single number. So treat that 4 times 10 as a 40. So the exponent part of the problem would be this part, 1.00375 to the power of 40. Depending on the brand calculator you're using, when you want to type an exponent, your button on the calculator either looks like this or like this. If you figured out how to type it correctly, you should be getting a run-on decimal that begins with 1.16. Experiment and ask a neighbor for help if you're not getting 1.16. Last but not least, now we can do the M in PEMDAS and multiply 200 times 1.1615. So a 1.5 interest rate is pretty small. This would be the sort of interest rate you get for things that are not really considered investments for the long term, something like a savings account, where you might need to access the money earlier than planned. So the investment interest is pretty small, 1.5%. Our next example is going to look at the sort of interest you might get from investments like stocks and mutual funds. Go ahead and copy this down. Well, 4% is still pretty small, but it's the sort of thing you'll get on a certificate of deposit sort of investments. All right, copy down the word problem, and then see if you could figure out how to identify what number goes with which variable. Pause the video here. Check your variables. We don't know future value, that's a question mark. That's what we're solving for, but they tell us that we currently have 600 we're planning to invest. The rate is always a percent, and you move the decimal twice and put a 0 and a gap if there is one. N is interesting. See how it says compounded yearly, meaning once a year? One time, so N equals 1. And T is 15 years. So when you plug it in, it looks like this. Now, most of you will have to type this in carefully in order of PEMDAS operations. So parentheses first. You have to simplify the exponents to a single number, and then you type that 1.04 to the power of 15. It's a run-on decimal, so I would just stop after the thousands place, usually around there, about 4 decimals in. And then you could do the multiplying step. Please double check that you are practicing the typing in the calculator with the exponents yourself and that you're getting the same answers, because that's honestly, for a lot of people, the hardest part of these problems is figuring out how to type it in their calculator. The third problem is different. While you copy the question down, I'll explain why. So up till now, we're using the compound interest formula to make predictions on how much your investment will be worth after a certain amount of time left alone if the interest is compounded on a regular schedule, meaning it's automatically reinvested, so it's snowballing over time. You can also use the same formula, though, to figure out how much you want to invest in a particular goal in the present day to hit a certain future value that you want. Let's say you've got a goal that's $30,000, like maybe your dream car, $30,000, and you really want to buy it 8 years from now. But you're not really planning to do the sinking fund approach, which is the other way we talked about saving for large purchases, where you put aside a little bit each month. You want to invest a lump sum today, leave it alone, and have enough for that dream car 8 years from now. So our future value, our goal 8 years from now, is to have $30,000, and we're trying to calculate what we should invest today to get there. So that's the question this time, see? Now we don't know the present value, the principal. However, identifying the other variables are the same as previously. The percent is your rate. Number of times compounded is from whatever word is after the word compounded in the question. Compounded monthly, that's 12 times a year. And T is number of years. So when you plug it in, it looks like this. You still have to simplify in terms of PEMDAS, and in fact, it's even more important that you follow PEMDAS with this problem than the previous, because even if you have a fancy calculator, you will have to break this down step by step, because when there's a variable in the middle of it all, you can't type that whole thing at once into your calculator. So ignore the variable and focus on parentheses first. And if you have a fancy calculator, you could perhaps type this whole thing in at once, but most of you will have to type parentheses first, simplify the exponent to a single number, and then use that exponent button to actually do the math there. Now, here's the deal. Think in terms of your basic algebra toolbox. When there's a variable you want to solve for, your technique has always been to circle it and figure out what to do to both sides of the equation to cancel out any numbers nearby that variable. So to cancel out a times 1.7478, you would divide. And you know the drill, whatever you do to one side of an equal sign, you must do to the other. So the principal is a little bit over 17,000. If you put a lump sum of 17,000 and a little bit extra into this investment today, when you check it in 8 years, it should hit $30,000.